Okay, so we're going to now start solving trig equations. So we're going to use a lot of what we've done in 5.1 and 5.2 here, plus all of our knowledge of, I mean, you can see on this paper where you've got radical 2's and 1's and plane 2's. Aren't those things that were in your special right triangles? Not that again. So in addition to that, we're using everything that we learned from the previous chapters related to our unit circle and kind of putting them together. So, day 1. We're not going to go through all of this today. Pretty much, I think we're just doing page 1 today. So we're going to solve a trig equation. If you look up here, it says the section is just like solving equations in Algebra 1-2, which is your first year algebra, but instead of solving for x, we're solving for sine, cosine, tangent, etc., your trig function. Do bear in mind that you will not usually see me multiplying or dividing both sides by a trig function. There might be some unusual situations where I might, but you won't be seeing me do it to both sides. What you will see me doing is adding and subtracting trig functions, and that's a legal move. And if you think in terms of algebra, didn't we add and subtract x values to both sides? But how often did you see us dividing both sides by an x or multiplying both sides by an x? Rarely, if ever, right? There's reasons for that, because when we're solving an equation and you do that, you're going to lose some answers. So, I want to get, on example 1, my sine of x by itself. Just pretend like it's 2y minus 1. What would you do? Yeah, we'd add 1 to both sides. So we're going to end up with 2 sine of x equals 1. Now I essentially have 2y. What do we do now? We divide by 2. And so my final answer, almost, my final answer as far as solving by for sine of x is 1/2. Now I have to pay attention to the fact that my sine of x is positive. I don't know what x is. We're trying to find the value of that angle. Your answers need to be in radian form. So although we see a 1/2 here, our guess is that sine versus cosine of 1/2 is either a 30 or a 60 degree angle, correct? We should have learned that through all of our work that we did before. So there's a couple of things that I need you to do. Thing 1, we have to consider which quadrant our answer could be in, because there's more than one answer. So sine here is positive. Sine of some angle is positive. Where is sine positive? Yeah, we've got all students take calculus, if you remember that. So all students is where sine is positive, so in this quadrant and in this quadrant. So quadrant 1 and 2. I'm going to draw my reference triangles in here, in those two quadrants. And my x is actually right here, or right here. So I'm just going to start with my first quadrant. It's easiest to work in. Sine is whatever what? Some old hippie. So I've got opposite over hypotenuse. And so my 1 would be opposite x. My 2 would be my hypotenuse. So here's my 2 right there. I don't need to know what this side is, but we all know it's what? Square root of 3. What's across from 1? What angle? What? 30 degrees, right? So x is 30 degrees. That's my reference angle. That's not my answer. What is 30 degrees in terms of radians? Yep, so pi over 6. If you don't know, you can take 30 degrees and multiply it by pi over 180, right? And so we get pi over 6. So this one's pi over 6. This one, bless you, this one is 30 degrees away from pi. So pi is 6 over 6, 6 pi over 6. So what's 1/6 minus, what's 6/6 minus 1/6? 5/6. So that means that the angle from here to here, because that's really the angle, this is a reference angle. We want the angle from here to here, and the angle from here to here. So our other answer is 5 pi over 6. 30 degrees is just our reference angle. Example 2. We can collect like terms also with trig functions. So again, I've got my sine of x is here, and here I need them together on one side. And so I'm going to avoid negatives as much as possible. So I choose to add a sine of x to both sides. How many sines do I have on the left? So 2 sine of x plus radical 2 equals, don't I have a 0 on the right? Could you have done this in the same step? Sure, you guys are pre-calc students, but these are your notes. So now we're going to subtract the radical 2 to get the sine of x term by itself. But I get 2 sine of x is equal to negative radical 2, and then divide by 2. And so we have sine of x is equal to the negative radical 2 over 2. So a couple of things. When we have a radical 2 in our special right triangle, we don't usually have a 2 along with it, do we? If you think of your special right triangle with a radical 2, isn't it 1, 1, rad 2? Didn't we have to rationalize this fraction? A radical ended up being in the denominator. So oftentimes when it comes to radical 2 over 2, it's a lot easier for you to think of what is actually the reference angle. Isn't x a 45-degree angle? And that's our reference angle. Anything radical 2 over 2 is always 45, whether it's sine or cosine. Remember that they're both the same. It doesn't matter whether it's sine or cosine. It's going to be a 45-degree angle. So now I need to look at where is it on the unit circle. Sine this time is negative. So again, opposite quadrants as example 1, right? Because that was when sine was positive. So I've got all students take calculus. So this is where sine is positive. So that means that this is where sine is negative. So I want to draw my reference triangles in quadrants 3 and 4. And so this is where x is this time. So x is still opposite over hypotenuse. And so opposite from x is negative, although it doesn't matter. I think it's not a negative radical 2. And then the hypotenuse would be 2. Do you see why I don't want you looking at it that way? Say that again? Oh, thanks. Do you see why for when you have rad 2 over 2, I don't want you using this because this isn't our normal special right triangle, is it? It should be really a negative 1 here, and that should be radical 2. Because your legs on your right triangle are 1, 1, rad 2. But this is negative because this is our negative direction, that's our hypotenuse. X is our reference angle of 45 degrees. What is the radian measure of 45 degrees? Pi over 4, right? Well, we need to go backwards. So if 2 pi is something over 4, wouldn't that be 8 pi over 4 over here? What's 8 pi over 4 going backwards minus pi over 4? 7 pi over 4, right? And then over here, this would be 4 pi over 4 because it's pi on this side. So what's 4 pi over 4 minus a pi over 4? Or, I'm sorry, are we adding or subtracting? We would be adding. So it would be 4 pi over 4 plus, because we're adding it going further. So wouldn't this one be 5 pi over 4? 5 pi over 4 is in quadrant 3. 7 pi over 4 is in quadrant 4. Now some of you have all those radian measures memorized, don't you? So you didn't even need to do this. But that's because you're way cool. Much cooler than the rest of us. Not a whole lot different than what we've done in the past, right? You're just using, I mean, you haven't, this is nothing new to you. We're just taking our knowledge of how to transfer trig functions. So today should be a little easier than when we get into some of this further. So let's look at example 3. This time we're doing something called extracting the square root. You can see that our trig function is squared this time. So in order to solve for a single trig function, we're going to have to eventually take the square root of both sides. But before we can do that, we have to get the tangent of x, tangent squared of x by itself. So we're going to add 1 both sides. We get 3 tan squared x equals positive 1. Divide both sides by 3. Tan squared x equals 1/3. To solve for just plain tan of x, we have to take the square root of both sides. But remember, when we take the square root of both sides, don't we have to do plus or minus? Because if the value of this tangent function is negative, if I square it, it's going to be positive, right? Technically, the square root of 16 is plus or minus 4. So we're doing the same thing with the trig function. So I end up with tangent of x only equals, what's the square root of 1? 1. And I cannot take the square root of 3. So it ends up as 1 over rad 3. You can have rad 3 in the denominator, but I caution you, I actually would stop here, personally. I'm not asking you for the value of the tan of x, I'm asking for what x is, right? True? And same thing as we used here when we had the square root of 2 over 2, that's not something that's normally in our special right triangles. But do we ever have a 1 and a radical 3 in our special right triangles? Yes. Our 30, 60, 90s, right? So I'm going to go ahead and leave it just like that. I'm going to look at my unit circle. My tangent can be positive or negative, correct? But technically, it can be in all 4 quadrants, right? But what is the period of tangent? Think of the graph of tangent. What's its period? What's the period of sine and cosine? 2 pi. Do you remember with tangent, it was only half of that? Our period of tangent goes from 0 to pi. So write yourself a little note to self. Tangent has a period. Somebody's screaming out there. Of pi. So only consider the interval from and including 0 to pi, but not including pi. So we're only going to look at quadrants 1 and 2. So my reference triangles are going to go in quadrants 1 and quadrants 2 based upon the fact that tangent has a period of pi only. So here's where x is. X is our reference angle. And tangent is some old hippie caught another hippie tripping on acid, right? So we've got opposite over adjacent. If you were to rationalize that denominator, your opposite and adjacent would look different, and you wouldn't recognize it in your special rate triangle, unless you've memorized that unit circle, which most of us have not. So for x, opposite would be positive 1 here, adjacent would be radical 3, and both of those in quadrant 1 would be positive. In quadrant 2, opposite would have to be a positive 1, but your adjacent would be the negative rad 3, and that's how the tangent in quadrant 2 becomes negative. I don't care what the hypotenuse is, it's 2 though, isn't it? What's my reference angle? X is 30 degrees because it's across from 1. So, but remember that's our reference angle. So my answer for x in quadrant 1, 30 degrees, we already said was pi over 6, right? This is pi over here, so since it's over 6, we're going to look at pi as 6 pi over 6. What's 6 pi over 6? This is my reference angle of 1 pi over 6. What's 6 pi over 6 minus 1 pi over 6? So 5 pi over 6. Why isn't it what? Because if one of your reference triangles is in quadrant 1, your reference angle is going to be one of your answers. But anytime your reference triangle is in quadrants 2, 3, or 4, it's not going to be a reference angle. You use that reference angle to add or subtract to pi, or bless you, or 2 pi, bless you. And so sometimes your reference angle is the answer, but sometimes it's not. It's a good question. Okay, then example 4. This time we have factoring. So now all of this is stuff that you practice in 5152. So factoring, and you're not necessarily going to be told, factor to solve the equation. But look at the two sides. I see cotangent and cosines. Both terms have a cotangent in common. And then we have this cosine squared. Usually when we factor, what do you have to do? What's handy to do when factoring? Do what? Yes, I have to have one side set equal to 0, correct? So you might want to write yourself a note, set one side equal to 0. So that would be the important part here. This is a side with a squared on it. So probably I'm going to move the 2 cotangent to the left. So I'm going to subtract 2 cotangent of x to both sides. Do I have a like term to 2 cotangent of x? Do I have a like term here? Nope. So I'm going to take cotangent of x times cosine squared of x, and I'm going to subtract from that 2 cotangent of x, and it equals 0. Don't they both have a cotangent of x in common? So that comes out in front of parentheses. Cotangent of x parentheses. If I divide this by cotangent of x, take it out, I'm left with a cosine squared x, and hopefully you can see where this is going. Well, maybe not. And then here, if I take that away, I'm just left with a minus 2. Unfortunately, or fortunately, depending on how you look at it, this is not a Pythagorean identity, right? This does not get replaced by anything. But remember what we did in algebra. If we had x, and let's say we had x squared minus 4 here, what did you do with that? X versus x squared minus 4. What'd you do? Well, okay, the x squared minus 4, yes, I'll grant you can factor that. I would not want to distribute because we just undistributed, right? Say that again? Why did I write this? Because we want to factor in order to solve. So when I subtracted the 2 cotangent of x from both sides, I got these 2 terms, right? Those terms are separated by addition subtraction signs. This term has a cotangent of x, that term has a cotangent of x. So they have one in common, which is the greatest common factor. So I pulled that out in front here. Then I divided each of those terms by cotangent of x, essentially took it away, and wrote down what I had left. Okay. So to solve, I'm not going to redistribute. I really can't factor this one because of the minus 2. So instead, you're going to take each of your different factors and want you set them equal to 0. Cotangent of x is equal to 0. Take this and set equal to 0. And then take the other factor, cosine squared x minus 2, and set it equal to 0. So I now essentially have 2 problems in one. So remember that cotangent of x equals 0 is going to be the easier one for us to deal with. So look at your unit circle. Cotangent is cosine of x over sine of x. in our unit circle, which is our ordered pair x, sine or cosine. In our unit circle, cosine is x and sine is y for our ordered pairs, correct? At each of these right here, remember these? In order for this to be 0, remember all of these ordered pairs are 1s and 0s or negative ones? What has to be 0, the numerator or the denominator, for the whole value to be 0? The numerator. So I'm looking for the numerator, cosine, to be 0. In other words, where are the x values 0? Now again, isn't cotangent limited to 0 to pi? Because cotangent is the inverse of tangent. It has a period of 0 to pi. So we are limiting this from 0, including 0, to pi. So we're only looking at quadrants 1 and 2. So my ordered pairs on quadrants 1 and 2 would be, right here, this is 1, 0. My x is not 0, that's my cosine, so I don't want that one. At 90 degrees, or pi over 2, my x is 0, my y is 1, so oh joy, oh boy, isn't that what I'm looking for? And then at pi, which we're actually not including pi in our answer, but at pi we would have had negative 1, 0. So our only choice between the first and second quadrant is pi over 2. Because tangent and cotangent only have a period of 1 pi rather than 2 pi. And so therefore, for this one, x is equal to pi over 2. So that's one of our answers. And then for this one, we need to solve for x. So wouldn't we add 2 to both sides? Cosine squared x equals 2. How do you solve for just plain cosine? Square root of both sides plus or minus the square root on the right. So we actually have 2 answers for the second one. So we get cosine of x is equal to plus or minus the square root of 2. And I'm going to put it over 1, just so that you can see its ratio. Cosine, caught another hippie, is adjacent over hypotenuse, right? Think of your right triangle that has 1 and radical 2 in it. Wouldn't that be your 45, 45, 90 triangle? Where is the radical 2 on that triangle? Is it a leg or is it a hypotenuse? It's a hypotenuse. That's not where the hypotenuse belongs, right? So let me ask you this. Approximately, what is the value of the square root of 2? Because theoretically, because it's plus or minus, we could have 4 answers here, right? Because cosine is a period of 2 pi. That means we're looking at all 4 quadrants. But what's the theoretical value of the square root of 2? What perfect square is 2 in between? 1 and 4, right? So the square root of 1 is 1, square root of 4 is 2. So the square root of 2 must be somewhere between 1 and 2. So here is the square root of 2. Oh, that would not be the square root of 2. I would try something else. How about the right piece? Square root of 2. 1.4. Almost directly in between, right? Guess what happens if I, remember how to punch this into your calculator? If I'm finding x, how do I punch this in the calculator? I do the inverse, right? Cosine -1. And if I want a degree, let's say, I want to make sure that my mode is in degrees. So my mode is in degrees. So I'm going to do inverse cosine of, we'll just do positive square root of 2 right now. Why did it give me an error message? Because why? Square root of 2 is approximately 1.4. What is the range of sine and cosine? The highest the sine and cosine curve goes is what? And lowest? 1 and -1. Because we go down to -1, right? Both of them. Isn't 1.4 outside of that range of 1 to -1? Remember when you go outside the range of 1 to -1, it's undefined? Sine and cosine are not defined there at those ranges. Unless, of course, we stretch it, but we're not stretching it here, right? So we've got no solution for this side. And you might want to write yourself a note that it's no solution because radical 2 is not in the range that we can plug in there. If it had been 1 over radical 2, then we would have been okay. Because 1 divided by the square root of 2 is within that range. So 1 divided by the square root of 2 is 0.7. So if I put that in there, then we would have been good to go. It would have been our 45-degree angle. Okay, so our only answer to this one is pi over 2. So sometimes you might have an extraneous solution, which means one that you have to throw out. All right, then the last thing I want to note for you, and this is important, you might want to highlight it, because it's going to relate to your homework that you're going to do. And if I were you, I would do your homework tonight because this is fresh in your mind. Obviously, I'm not going to collect this because you're for 2 days because of the fact that I'm swapping your quiz out. But look at this reminder here. I just want to remind you that cosecants and sine are inverses of each other. So if you're told that cosecant of x is 2 over radical 3, that its sine must be rad 3 over 2. So if you have a problem that has cosecant in it, or cotangent in it, or secant in it, you want to switch those out when you get down to the final, like when I'm down to like here. If I'm down to here and I'm looking at cotangent, I probably want to swap it out for tangent. Now the only reason why I didn't on this one is because it was 0. If I've got cotangent or tangent equaling 0 or -1, then I'm not going to probably swap it out because I can move the order of pairs quite easily. But if anything else, if I've got cosecant, I'm going to swap it out for sine and take the reciprocal. If I've got secant, I'm going to swap it out for cosine and take that reciprocal. Same thing can be done for cotangent. I'll swap it out for tangent. But it's specifically helpful on questions 13 and 15 that I assigned on tonight's homework. Okay? So I will answer all questions when I return. But that should get you enough to get through the first part of your assignment.